Thank you guys for joining, and Tim and Scott, thank you for the time today for me to help our customers understand where AWS fits in manufacturing, and specifically within the aerospace industry. Ultimate goal is to help you understand how we look at Industry 4.0, but also other areas within the manufacturing environment. And that's one of the unique things that we have, is that full view of the business, not just one or two different segments as we go forward. So can we go right into the next slide? And when we look at the manufacturing environment, we have to understand the problems that you have. And these are general problems that many of our industrial customers face in your day-to-day operations. And this is things like data access. Up until probably 10 years ago, your networks to your factory probably were not even connected to the internet. Many times now that still goes through 3, 4, 5 different firewalls, different protocols and different capabilities that are going down there. Many of our customers across many industries have machinery that's 30 years old or 40 years old, probably hasn't been turned off in that time frame. Probably still uses dip switches, so forget about even getting data off that machine. At the same time, the average manufacturer right now, average being not fully automated, not manual, produces about 1.5 terabytes of data per location. Now, that's a huge data set. And a lot of that data is stuck in these different databases that are down to the machine level. These could be historians, these could be MES systems, other type of data sources that are out there. And the other problem with that is it's not just that there's a huge set of data, but there's disparate machine data out there. You have over 350 different protocols just in the manufacturing space. Doesn't help when you're trying to get that information onto a data lake and drive forward. We'll talk about how we're actually helping clean that up and make that disparate data across the board become more normalized and become more intelligent as we go forward. At the same time, having that data management across these huge data sets, and by the way, 4G is not going to solve that, and 5G is not going to solve that, and 6G probably won't solve that, is how are we going to help understand what data does need to be moved to the cloud and what data could be stored locally to help unlock some new insights for you. Then you look at scale. You've got hundreds of machines, and many times these machines are very similar, maybe not the same, but very similar across your different locations. You now have, again, the disparity of data sets, the disparity of protocols, and now putting that not just one time, but hundreds of times as you start to go forward. This has to be in a secure environment. There's no doubt about it that security is job one within the AWS environment. And in fact, our next protocol, our next area is really going to be talking about security for you, what AWS brings for a security environment to ensure that that data is secure and your operations are secure from that standpoint as well. The last thing on this slide is that you need this information in near real time, if not real time. Now, what we're talking about is not replacing your HMI systems and that real-time information that you're getting from your SCADA and your control systems. What we're looking at is augmenting those capabilities and that information flow to give you better insights across those. At the same time, what we are looking at is looking at some of those real-time data sets and looking at what we can add on top of that. Is that quality management? Is that production insights and other things to go forward from there? Overall, these challenges are what we've been doing the last few years to understand what we can do from a technology standpoint to help solve these issues for you. Go to the next slide for me. When we look at this, we've broken down many of our different customer bases into what we call workloads. Think of these as different departments. Think your engineering and design, which Walker talked about earlier, and how we can do with the high performance computing and help accelerate that time to market of new product introduction, lowering infrastructure costs, and really improving collaboration across your engineering and research teams around the world in a secure environment that's something going to scale as you start to move forward. When we move into the shop floor, that's when our production and asset optimization is going to help you get better insights about what my assets are doing, how I can reduce productivity downtime, in other words, unplanned downtime. Where are failures occurring and why are they occurring? And could we get further in advance of these to really move around where that failure might be happening? At the same time, in a production line, you have quality issues. How can we inspect quality in real time, not just at the end of line, but can we now improve in line type of quality checks and not using human beings to do that quality check? Can we build systems and processes in place to make it easier to understand what that quality check is and how we can react to it before it becomes a major issue? When we move also on the shop floor capability around worker safety and productivity, how do we improve that employee productivity to really give them the right information at the right time in a secure format in the right capability format? And not just give them an overload of information, but the right information is the right key from that standpoint. Moving data into actionable insights so people can not just get a report, but are also guided about what they can do from solving that as they move forward. Moving into what is our supply chain capabilities. And as you know, Amazon is one of the biggest and most incredible supply chain capabilities out there. And what we're doing is working with Amazon and our customers of what Amazon does and take those capabilities to many of you, our customers out there. While we may not have Kiva robots to sell to you, we have a lot of the same processes and how we've moved our supply chain into a fully digital insights that we can understand what you're going to be purchasing very soon. And that then works backwards into where do we need to make that purchase? Where does that product need to be sent to? So we can do low cost routing to you to get it into that time that was promised. And then finally, smart products and machinery. Now, as you probably know, AWS makes a ton of different services for smart products. In the consumer market, these could be the Echo devices that you hopefully are using all over the house, Peloton bikes like what's over my shoulder, or other things that are out there to really enhance and add more intelligence to those products out there. It enhances that user experience. It really adds new capabilities to understand how the products are being used and where those products are needed from an improvement standpoint. What we're looking at and what we're doing right now with many of our customers and partners in this space is take what we've done in the consumer space and bring that into the industrial market. So why not use voice in the office? Could you walk up to that machine and go, machine, how are you feeling today? And it goes off and it runs 4 or 5 different predictive models to understand the health of that machine in real time to allow it to come back and say, you know what, Doug, I'm doing good today. I don't see a failure in the next 2 weeks. The data is there. The data lives on the machine. The algorithms are available for us. Could we use voice to do the interrogation? Could we have that capability going on? At the same time, there's a big drive in the market to move into machinery as a service or hardware as a service type of capabilities. No longer do people want to do a capital outlay to start off factories to really move into that capability. So could we work with the machine builders to start doing machine as a service capability? An example of that is one of our customers in the conveyance system is looking at linear feet of movement per day. In other words, you're not going to spend millions of dollars to buy a conveyor belt. You're going to spend on a daily basis the type of information flows that are going to move product from point A to point B. Now that could be a conveyor belt, that could be robots, that could be other things that are in place to allow you to have that capability. But you, as the user of that robot or of that service, really just cares about items moving point A to point B. You're willing to pay for that if they make sure that happens in the right format, the right time, and in the right capability when it's needed. So what we see across the board is many times these data sources are out there. And what we're looking at is how can these data sources be integrated as we move forward. Go to the next slide and we'll start talking about what we call as a manufacturing data flywheel. The manufacturing data flywheel is a way to start to look at new use cases across those different divisions or those workloads that go from that last slide. So think of telemetry coming off your products. You have information flows that are off of there in real time or near real time so you can understand how that product's being used. Right now, that product probably goes into manufacturing warranty information. It might go into R&D, but it should be going into R&D so your R&D department can use real-time information insights from actual use cases. In other words, how's the product being used? What type of environmentals are from that aspect as well? That will allow you as that provider of that product to design the next product better. In other words, could we be actually using how customers are using our products to design the next generation product as well? We can then produce that product and maybe even do things like over-the-air update. I'm sure many of you have smart vehicles nowadays and you get that over-the-air update periodically. You get the alert on your dashboard that says new features are available for you. Well, now that product and the process, that product designer can actually just do that as a software update over the air. That makes a better loyalty, that makes a better user experience, and it really drives that customer stickiness. As we know, that customer stickiness is the key to making that customer loyal to you as you start to go forward. But now that that engineering team or that R&D team has looked at that product portfolio, is designing the next generation of product using that HPC on the cloud, the type of systems that we're bringing for the virtually unlimited scale out and compute capabilities of the environment for you. Now, what you typically do is you first design the product, and then you design the process for the product. In other words, what is the process that we're going to do to make that product in my manufacturing environment? Historically, those were two different departments. We have our process design, and then we have our actuals. In other words, the factory, what we're doing out there. Typically, the process designers would build that process out, they would push that out to the factory, and then they would let it run. But then the process starts to change. They start to see process improvement capabilities. They start changing what's going on the shop floor. Maybe they get new machinery down there or new vendors that are providing new capabilities or new insights. Well, what we want to be able to do is make sure that that process design is aware of these changes in real time, as well as potential issues. So many times that process design says, and here's how many we can produce in a day, and with this type of quality level, and so on from that standpoint. If you're constantly seeing that process improvement and able to have that capability go forward, you should get that information back into what the design of the process was as well. Now that we have that process design and the actual process linked together, we can now do what's called DFX, or design for manufacturing capabilities. We have better understanding of the product. We have better understanding how that product's being used. We have a better understanding of the factory and what's happening from that standpoint. Now we can really truly understand what we should be using from a design standpoint as well. So right there, we need that information to go back and forth from the factory, live telemetry information of my robots and my machinery to understand production plans versus actuals, my process design, how it was designed versus how it's actually being run, so we can do the new improvements as we go forward. That, of course, will make our product better for the field. Now our users have that capability, and we get that feedback back to the factory of how the product's being used, and we can really design that type of capability. Now, trust me, this is huge. There's a lot of different things that are going on with there, and that's why we look at this as a flywheel. You don't have to say, I need to build the whole thing at once. What we're able to do is work with our customers to say, what are one of these levers? In other words, the white little buckets on here that might allow you to improve your business more. Is it OEE? Is it uptime? Is it 2 more products out per hour or per day or per week or per month? Is it customer satisfaction so we get that capability? Is it very quick new product introduction that we don't have to worry about being behind our competitors? Well, all of those have a value to you as a business. So many times we work with our customers to understand those levers and drive where those improvements are. Let's look at some of those levers on the next slide. And I mentioned OEE, your overall equipment effectiveness, over on the far right left-hand side here, where we look at asset efficiency and quality capabilities. Those are made up of levers within the lever as well. So you have optimized capacity, asset utilization, lower changeover time, lower downtime. In other words, better planned capabilities for maintenance and other things from that standpoint. When our customers move down this path, they see asset efficiency by up to 20% improvement capabilities. At the same time, when we talk about improving over quality, they see a 35% improvement in quality capabilities of products going out the door. That's by reducing scrap rate, increasing fill rate and yield capabilities, and lowering lead time to your customers. Now, those calculations are OEE type of capabilities. And what we do is many times work with the customers, again, to understand those levers. Everybody's OEE is calculated a little bit differently depending upon your business and your process. But if we can improve that by 0.5% or 1%, or by improving one of those values within those, we can start to see top line and bottom line growth and benefit to your business as you move forward. At the same time, when we look at reduced cost capabilities, our customers come to us and say, by implementing Industry 4.0 capabilities, we're looking at lowering our cost of labor, our sourcing capabilities, lowering our inventory levels, lowering maintenance and lowering warranty across the board. Now, go back to that last slide. Those costs are different costs across those different areas within that flywheel. Inventory levels are due to manufacturing and being able to understand better manufacturing capabilities. That maintenance costs could be within your factory, or that maintenance costs could be products running in the field and understanding if we need to do maintenance on those products before they fail, which then relates into warranty. That warranty could be runtime of what's happening out in the smart products that you're building, and understanding in closer to real time where failures are going to occur so you can actually plan maintenance and start to sweat the asset better as you move forward. At the same time, when we look at safety and sustainability, we look at a reduction in safety incidents by doing things like better training capabilities, by looking at new ways to visualize what's going on in your facility to understand where those safety issues are and start to mitigate where those actually are happening from that standpoint. This improves your employee satisfaction. Improving your employee satisfaction will help with retention, and retention is a big issue. Right now, as we all know, we can't get enough employees. We are trying to get back into our full operations, and it's very difficult right now. So if we're able to improve that employee satisfaction, it will help us also recruit new employees. At the same time, this also is an incredibly powerful way for us to get better on our sustainability vision. Data-driven sustainability is a goal of many of our customers, looking at where the insights are of power and utility and other capabilities, and understanding where some of this is being used so we can react to where it's not being used or where it should be used efficiently. And of course, that will help drive the environmental impact as well. Let's move to the next slide. When we look at the pillars of Industry 4.0, we look at autonomous robots, simulation capability, big data, augmented reality, additive manufacturing, cloud, cybersecurity, Internet of Things, and vertical and horizontal integration. We feel that there's a lot to happen from a cloud environment. Again, you look at these different levers, you look at these different silos of data, and what we want to be able to do is integrate that information to allow you to do the type of outputs that you're looking for. These outputs could be integration of AI and ML into your industrial processes to get better insights, better capabilities out there of what's been happening across those different silos of data, but understanding not just the individual silos, but again, the integration of those silos as well. We, as a cloud provider, need to make sure that these work on premise as well as cloud type of capabilities. So can we run the same workloads in the cloud that we can now run in your facility? At the same time, what we want to be able to do is leverage the skills that you have, the skills that you may not have, to be able to train that up to help lower your cost across the board. If we look at these capabilities, they relate to the last slide of where you're going to see potential impact within your business and being able to drive those capabilities to have those new insights as you move forward. Let's move to the next slide. And AWS does this on a daily basis. While Amazon has been around for 25 years, we've been built from a smart product, smart factory, smart initiative since day one. Hard to understand that, but when you make an Amazon order, you actually are looking over 400 different manufacturing sites around the world where we have locations. Now, we're not manufacturing, but we use the same processes of continuous improvement, AI and ML and robotics and conveyance systems and PLCs and SCADA systems and control and MES, and keep going with everything identical to what you have in your facilities. Our typical manufacturing environment of our fulfillment centers, and let me pick on the AR sortable, which is Amazon robotic sortable locations. These are 1 million square feet. They have about 6,000 robots in them, and anywhere from 17 to 22 miles of conveyance systems, working with about 1,500 people in harmony to process about 1 million orders per day. Now, during Amazon Prime, that flexes up to about 1.5 to 1.7 million orders per day. To do that across 350 different locations is a huge undertaking between a hybrid environment of both on-site in case the networks go down, as well as cloud capabilities. So when you place an order, you're placing the order against the cloud inventory levels that we have. We then validate before we push that down to a location of where that order is going to come from. Within 30 seconds of you placing the order, we've done a few things using AI and ML. We understand where the inventory is. We understand the replenishment of that inventory. In other words, where else might that inventory live in case we need to sell it again? Then what it does, it looks at low-cost routing. In other words, can we get it to you in the promised time frame, as well as then looking at how we're going to do all of the steps to move from a robot that has to go pick it up to a human being to take it off the shelves, to put it onto a conveyor belt, to move into a process to make sure that we deliver within time for you. Because of the data that we get, and it's an incredible amount of data that we get on a daily basis, we can now move from when we move to 2-day shipping to 1-day shipping. We can also start to improve more capabilities and better insights and really understand what that whole intelligent level is. Now, what we've been able to do is take a lot of these capabilities and a lot of these challenges, exactly like your manufacturing environments, and bring those best of breed capabilities that we're doing on a day in and day out basis within our facilities to you, our customers. Let's look at a couple examples of this on the next slide. What we've been able to do is move more into a hybrid environment. Most people think of Amazon and AWS as what's on the left-hand side, the cloud. And we've talked about availability zones. We've talked about point of presence capabilities. Hopefully you've heard about wavelength, where we're integrating into 5G infrastructure to be able to bring cloud closer to where that data lives. What we've done as well is be able to take the exact same hardware that are available to you in our availability zones to put into AWS Outposts, which is a way for us to actually put that hardware into your locations. Well, why do we need it in your location? Multiple reasons: latency, networking capabilities. Remember, I've mentioned 1.5 terabytes of data per day that are being created and need to be analyzed. You're not going to move that over a network in a real-time environment. So now with being able to bring Outpost and Snowball, which is our data storage capability, we're able to now have that environment from a hybrid capability to run with your environment in your factories and your facilities to be able to ensure that latency is not an issue as we go forward. Now, we look at two products on here called Snowball and Snow Cone, and these are really to store data and start to run operations. Snowball is great for storage on a site level. It looks like a disk array. And what Snowball basically does, and when it first started, was a way to move data physically for you. What we've done is add more compute capability for Snowball Edge, where now what we can do is now start to run actual product and actual hardware software on it to start to do analysis. We can start to do trends. We can start to do some predictive maintenance capabilities. Snow Cone is even a smaller size. Think of this as a portable disk to be able to run down to a machine or a line level. And again, it can run more for data storage, but it can run some compute as well. And in fact, we now have IoT Sitewise running on Snow Cone, where now we have that hardware, which is managed by AWS, and software to be able to integrate the data storage capabilities. We'll talk about Sitewise in a couple of minutes, but the other capabilities that we have from an edge environment are things like FreeRTOS, which is our runtime operating system to run within microcontrollers. So now you have a free runtime operating capabilities, which integrates across the whole stack of the portfolio, including into IoT Greengrass and our AWS IoT product portfolio. This is a way for us to run all of those services and those functions that we've been talking about for the past couple hours now within your environment, and it's down to an edge environment. Other capabilities in there are things like RoboMaker, which is a way for us to look across those different environments and give you a single pane of glass across your robotics or automated material movement capabilities. Instead of looking at each vendor and then building it up from there, we're working with those vendors to get that data unlocked so you can go from a movable robot to a stationary robot into a conveyor belt and give you that single view about what's going on. Let's go to the next slide. And last year at reInvent, which is our large customers environment that we have, all of our customers come together and start to learn about new products and new services and new capabilities that we launch. We launched some specific industrial services. Many of these were being done within our Amazon environment, which takes us into how we're taking the best of breed of what we use many times. I talked about IoT Sitewise, and IoT Sitewise is a product portfolio that collects, stores, organizes, and monitors data from industrial equipment at scale. Now that sounds very similar to a historian. It sounds very similar to your MES type of providers, but it's not. It really is a way to just do the analysis of that data. We can add capabilities to do control as well, but it's a way for us to build it once and deploy it at every location. This could be down to a machine level, a line level, or a site level to be able to understand all of those different capabilities. Think of this as an OE engine to be able to go from one item and roll that back up as well as back down from those capabilities. Another product that we launched was AWS Panorama Appliance. And this is a way for us to add computer vision to the existing cameras that you may have. So what we've done is built a hardware device, which has the GPU and CPU and storage capability as a managed service for you. As you probably know, nowadays it's so hard to get the right CPUs and GPUs and then scale that and understand which one is right. And in 2 years, you're going to need to replace it. So as a managed hardware capability, we're going to build this and deploy this within your locations. We attach to your existing IP cameras that are out there, pushing network capabilities over those video streams. We basically put this as not as a staging point, but as another way for us to analyze that data. So now computer vision could actually add more capabilities into here. We then have a Panorama Appliance marketplace where many of our customers or partners are building different computer vision algorithms. These algorithms could be very quickly deployed within Panorama Appliance on top of your data sets, your video data sets, to now add more capabilities. These capabilities could be anything from looking at users. Are they in the right area? Do they have certification to go in those areas? It could be some capabilities that we've built with partners over the past year or two. Things like, are you wearing a hard hat in the right area? Do you have your PPE on? Are there too many people in a room? And those are now things that you can very quickly run right onto the Panorama Appliance. You can click and download and deploy very quickly. At the same time, what we're doing is no longer just looking at this to be able to run as an appliance, but working with camera providers. And how do we take the same thing that we're doing with Panorama Appliance and pushing it out to the new cameras that are coming out? So many of these cameras are now including things like Jetson and NVIDIA chips built into it to be able to now do that computer vision capability on the camera. No longer pushing it over the network, to having those alerts come out from that capable camera to be able to have that truly at the edge as we start to go forward. Now, to support vision capabilities, we also launched a new product called Lookout for Vision. What Lookout for Vision does, it moves away from machine vision into computer vision capabilities. In the past, for machine vision, what you'd have to do is train the model for every variant. The variant could be angles. The variant could be different lighting systems. The variant could be how is the scratch looking at different types of capabilities from that standpoint. Just the lumens in your building makes you actually do hundreds, if not thousands of hours of different training for a model and video storage to be able to go from that standpoint. Well, with computer vision, we want to just train for the defect or the anomaly. So now what we're able to do is very simply look at what a perfect value looks like. Maybe I'm doing surface detection and I want to understand scratches or abnormalities on the surface before I actually put it onto a product. Well, in the past, you'd have to first train for the perfect model, train for all the different environmentals, and then build the model from that standpoint. Now, what we do is basically build the model for the perfect gold standard. Anything outside that gold standard, you can start building tolerances out there. We've been able to build Lookout for Vision models with as small as 30 frames of video. In other words, take it, build it very quickly, and then deploy it from there. It comes back and shows you where those anomalies are and where those defects are. What we see Lookout for Vision doing is working with many of our customers to do what I mentioned earlier, to be able to allow in-process or in-line quality checks. No longer do we just look at the quality check at the end of the line, but what we want to be able to do is look at every step and every process to be able to start looking at root cause analysis. Just because you see a quality defect at the end of the line doesn't mean you know where the issue occurred. If we can start looking at more and more of that computer vision capability in process, we can actually start looking at the root cause analysis of quality as we start to move forward. That improves your quality capabilities, lowers your scrap, and everything else that we were talking about earlier from that OE standpoint. And this is not using human beings. So it's able to scale very quickly using that scale out environment that we have to be able to then build those environments for you. You can build this once and deploy many, many different times out there with minimal changes except for what that anomaly is going to be looking like as you move forward. At the same time, what we've been able to do is another capability called lookout for equipment. The lookout for equipment is to be able to drive across your industrial sensor data. And what it does is it actually detects the abnormalities that you might have in those data sets out there. What we do is take the existing sensor data that you have, and we change the whole model around prediction. So think of building a predictive maintenance model. What you do typically is you first extract the data, then you build the model for that data as you go forward. You find the abnormalities, and then what you do is you actually start to tune that model for what those values are as you go forward. Well, then you have to have a data scientist. You have to understand what those models are and tweaking of that model and building it as you start to go forward. What Lookout for Equipment does is basically takes your data, takes a subset or actually a big set of different models for you, and actually looks at the right model according to what your data set is. It takes that model, builds it, and then releases to you where the abnormalities are without user interface. Then what you're able to do is include things like your maintenance logs. Your maintenance logs will tell you good information about what was fixed and how it was fixed, which starts to build that predictive model as you go forward. Let's take, for an example, a machine that we're working on recently. Very simple machine, 5 sensors on it. Now what it did was first it looked at sensor 1 and built the right model for sensor 1 and looked at the behavior and then found out any abnormalities or defects in the data that was going across from there. It then did that for sensor 2 and sensor 3 and sensor 4 and sensor 5. Then what it did, it started looking at correlation of all the different data sets, all the different sensors out there. So it actually built a data model automatically, by the way. Remember, I was using that automatically standpoint, where it looked at sensor 1 and sensor 2 and built the correlation between those. Found all of the abnormalities in that data set for you. Then did that for sensor 1 and sensor 3 and all the permutations. And then did it for sensor 1, 2, and 3 and all the permutations, and 1, 2, and 4, and so on from that standpoint. Now, historically, that would take weeks to do, and you would have to be able to go in and fine tune it and keep it running from that standpoint. With Lookout for Equipment, it does it very quickly in less than hours. I mean, we're looking at going from weeks and days down to hours to be able to understand where all those defects are, where that abnormal behavior is occurring from that standpoint. Then when you bring in those time series databases of your maintenance logs, again, what you do is you physically match, this was what we maintained, this was the issue that we saw, and that builds that predictive model as you go forward. That then drives to allow you at scale from that standpoint. Now, the great thing about Lookout for Equipment, in my opinion, is that it looks at it from a different data set for each machine. Historically, when you do a predictive maintenance model, you would go in, you would build the model, you would put it onto the machine data set that you have, and then you would fine tune it from that standpoint. You go to a second machine, you may have different sensors, you may have more sensors, you might have a different provider, you may have different software stack on it. It might go from a Rockwell to an Emerson or a Honeywell or an ABB or a Siemens or other data sets from that standpoint. Well, that means that data model that you built doesn't work. Well, what we're doing is basically obfuscating the data from the issue. So now it builds that model for you. It doesn't matter if it is Siemens or Rockwell or Emerson or ABB. It looks at it and builds that custom model for you for each data set, for each machine as you go forward. And again, does that very quickly to allow you to scale and drive that new insight and capability as you move forward. We see this as a way for customers to be able to scale the predictive capabilities, not just from one machine, but to hundreds of machines and capabilities as they move forward. And to prove this, one of the things that we did within Amazon was another product called Monitron. Monitron was actually built for us around our rotating equipment. Think of the motors that are running across our conveyance systems. You've got rotors that are running pretty much 24/7. So what we did was we worked with a company to build a sensor for us. That sensor has on it vibration and temperature. We take that sensor, we glue it to the motor, and very quickly we QR code the sensor and then a gateway. On that gateway, it has a lot of the intelligence built in to understand first where the sensors are. Second, it has all the northbound connectivity. In other words, how do I get the data from that gateway, from that sensor into an AWS environment? Once it drops that information into an AWS environment, it actually very quickly runs a report for you. And you can see live information flows on your phone within minutes. We've had customers be able to install this and get this running in probably as low as 10 minutes. Now, yes, you need to ensure that you have your security open with your firewalls, you're able to understand the data sets that need to come through from those standpoints. But once that happens, it's as simple as sensor to machine, sensor to gateway, gateway to cloud, and your environment is running from that standpoint. We see this one as a way for other sensor environments to take the architecture that we've built and bring that to their sensors to allow almost anybody to be able to install as quickly as we've been able to look at from that standpoint. We don't want sensor environments to take weeks to install. It shouldn't. It should be as simple as minutes to install type of capability. So across the board, what have we been able to do? We've been able to unlock some of the data that exists, really take those new information flows for you, be it video capabilities or computer vision capabilities or data sources, as well as a planned or a built-out end-to-end environment, which was proven within our fulfillment centers to be able to deploy very quickly and at mass and give you insights around typically what was a critical asset, but many times an asset that didn't have a lot of data on it. Let's go to the next slide. Other things that we launched within our reInvent was really what we called our industrial capability. What we did over the last couple of years, what we've been building out are actual solutions built for you, our customers. These solutions are over on the right-hand side here with Amazon Virtual Landon, Amazon Connected Factory, smart product environments, machine to cloud connectivity, predictive maintenance, our device simulator, as well as scale-out computing, which you heard about earlier. These are pre-built reference architectures to allow you to very quickly stitch together all of those different services that we have and do it from a use case environment. So if you're looking at how do I understand how I get data from a machine into a cloud environment to allow me to do predictive maintenance, we have the machine to cloud connectivity and the predictive maintenance reference architecture to build those together into a seamless environment. Let's go to the next slide. We've also done this with our partners. And these partners could include consulting partners. And we have many of our consulting partners who are taking those capabilities and building them to scale, as well as technology partners who are going out there and actually have different solutions available for you. Many of these are available on our marketplace that you can click and download across your data sets to get better insights as you move forward. Let's go to the next slide. And these partners are going to help you have that accelerated time to value. This could be Autodesk with Ford, which is available very quickly for you to download across the marketplace to get that new insight capability of your design environment. Deloitte with their Smart Factory Fabric, which we'll talk about as a use case in a couple minutes, of building that smart factory environment, that reference architecture of not just one use case, but 8 different use cases with more to come as we've had those out. Hitachi Vantara with Lumada to be able to build that same architecture, not just the data lake, but data lake and reporting and connectivity to build that end-to-end environment. PTC driving their ThingWorx application to an AWS environment to allow you to scale out your design capabilities, not just your design capabilities, but your IoT connectivity and how do we have that integrate into our environment. Great way to go after the 350 different protocols that are out there and not have to worry about writing hundreds of lines of code for protocol conversion into a transportable normalization of that data. Siemens MindSphere to allow new insights and capabilities, and over 80 different applications and use cases very quickly deployed across a SaaS environment. Tensor IoT with smart insights to have reporting and capabilities off that data lake that you've built, and Wipro with track and trace capabilities. And trust me, there's more that are out there. In fact, if we go to the next slide, we see a not exhaustive list of many of our partners who have built solutions on top of us. These are consulting partners that have already built many practices to be able to go from that end-to-end standpoint. Those technology partners to be able to go either integrated into their hardware capabilities at the edge or how their software is now running on the AWS environment to allow you to really extract that next level of value as you go forward. Many of these customers and partners are really available for you to say, what are you trying to build? How do we build that? And how do we drive that? What we're able to do many times is say, you know, instead of building something, I may have something prepackaged for you, allow you to get that time to value very quickly. If we go to the next slide. I want to talk about a couple customers who have actually done this, gone through this journey. A great use case is Lockheed Martin. What they wanted to do was really jump into that smart factory environment. They wanted to go into that modern day manufacturing decision making in a secure environment, bringing together the best of IT and the best of OT, also spanning all of its enterprise levels and all of its facilities. And I think that's a key. Many times you can do this once, but what Lockheed Martin said is this can't happen just once. This has to happen hundreds of times out there with every facility, every machine, every workload that we're looking at. So Lockheed Martin chose our AWS IoT capabilities, that edge environment that we had with Greengrass, to be able to unlock that data export from the machinery that was sitting out there, to have that data go into Kinesis and into an S3 bucket to be able to build that data lake out and allow that data to be both normalized and then actioned upon. They moved away from paper-based tracking and reporting, optimized labor capabilities, and gave new insights into what its manufacturing operations were driving from that standpoint. And yes, in a fully secure environment, both from data at ingest, data at rest, and data in flight, as well as data on the cloud type of capabilities. This moved that data into actionable insights. So those users actually are being told this is what is starting to happen, not just seeing a trend, but actually being able to give and guided what is going on as they move forward. Another customer on our next slide is Spirit AeroSystems. And together with partner Deloitte out there, we actually implemented the Smart Factory Fabric. So Smart Factory Fabric is what we're talking about earlier with a pre-configured suite of cloud-based Internet of Things applications to accelerate the transformation of many of our customers out there. This uses AWS IoT, AWS cloud environment to actually deploy those cloud applications very quickly because the data is now being ingested into there. This helps reduce costs by increasing visibility into every action and every capability across what's going on the shop floor. This optimizes production, improves quality capabilities, and minimizes unplanned downtime. So across the board, when we implemented this with Spirit looked at this and said, I've got tons of different data sets out there. I have different platforms. I have different providers. I have different information that's out there. I've got a huge, diverse, different customer set. Many of you who are on this call out there, and they all have different requirements out there. I have huge part sizes that I need to use, but guess what? Sometimes we lose them. At the same time, we have thousands of different part counts and part combinations that go out from that standpoint. And each vendor, even though they may have the same part, has different SKU numbers and different capabilities as they go forward. And when you multiply this by hundreds of locations and thousands of different suppliers that are sending us product to be able to build these capabilities, and many times long lead times, which hopefully is not being impacted right now. So we implemented the Smart Factory Fabric, and this actually was a way to build a digital thread that went from product that we're receiving to products out the door. It goes across all the infrastructure and all the information across the factory floor, including scheduling, including machine monitoring, machine visibility and material visibility, and a command center to give everybody understanding of what was going on. They're able to understand in a single pane of glass all of the aspects that were happening so they can react before they become issues. Since the implementation, they've actually reduced their labor time spent on workers looking for parts by up to 50%. According to Terry George, in collaboration with Deloitte and AWS, we're working to quickly implement smart factory solutions to our manufacturing operations that will lead to an increase in production throughput, asset utilization, and is helping reduce inventory. What they're doing is now looking at different use cases that are being integrated into the smart factory fabric. Now that that data is there, we can add more and more and more capabilities to that and start understanding the what now and what next type of story that people are looking for. Let's go to the next customer. Genie. Genie is actually a brand from a company called Terex, based out of Seattle, Washington, actually out of Bellevue, Washington. They're a global manufacturer of lifting machinery. So just as you see here with these scissor lifts that open up and bring things up to that area, they wanted to improve the quality and the perception of their lifting equipment. Some of that quality was actually finished goods They had chipped missing and peeling paint sometimes that was coming off the end of the line. This created warranty claims. And sometimes this it got through quality checks. Just happens. Again, people are looking at the quality check. How do we reduce those quality issues as they go forward? What we did was we actually helped Genie implement a scalable, secure, and repeatable paint processing system. This spanned from the factory floor, i.e. the paint room, to the cloud. It used IoT site-wise. And what it was able to do was ingest all that data, organize and analyze the data, and understand where inconsistent and improper pre-treatment was happening. This allowed corrective actions to be occurred before the product got painted. What that did was improve their paint quality from that standpoint. They've now connected this to 2 plants and actually are deploying this up to 7 plants across the next couple months as they start to move forward globally. This allows them to reduce warranty claims, improve paint quality and durability of their lift products, and increase customer satisfaction. The worst thing they want to do is send a product out there that has issues on it. And here they're able to see that before it ships as they go forward. The next customer, please, is Volkswagen Group. And Volkswagen Group 2.5 years ago announced that they were going to go out and build the next thing and the next big thing for both internally and externally. What they did for internally was the industrial cloud, and this was a way for all of their factories to build a foundational service. It spanned from cloud to edge capabilities and was actually implemented at all of their plants across the globe. What this does, it allows the ingestion of all of that data using AWS IoT Sitewise, stores it in a data lake, and uses custom web interfaces to allow you to understand near real-time status of machines. At the same time, what it did was it built a single OEE dashboard, which can go up as well as down. And what I mean by up is it's an enterprise level dashboard for OEE. You can compare across all your facilities and get a single OEE, but then you can drill down to a site level, a line level, a machine level, and actually understand the compounding effect of OEE across any of those capabilities. This started with their cylinder production line and scaled up and out to other capabilities as they've been moving forward. What this is also allowing them to do is scale this to their suppliers. So in the industrial cloud is now scaling out to have that same type of data move into what their suppliers do. So now that quality information from their suppliers is being put into the industrial cloud, which is consumed by the sites to understand quality products coming in or potential failures that they might be seeing or issues as they might be seeing going forward. This is scaling, and what they're able to do is now build one use case at a single location, but scale that all across 133 locations as they go forward. In the past, typically what would happen is a factory would build their one use case and build their solution for that use case. Another factory would build their solution for their use case. Different things might have the same use case, the same issue, but completely different solutions and how they built it. Here, what they're able to do is now build it from a scale standpoint, which is helping lower cost and helping people really focus on where the business is, i.e. building vehicles to move out of the locations. Let's move to the next one. Module is an example of a partner of ours who actually is going into health and safety capabilities. Module actually builds solutions and hardware for our customers. One of their first examples was a smart belt. And this smart belt looks like a belt, but it has multiple sensors on it. Those sensors could have up to 8 different sensors built into it. This could be stress and strain and twist. It could have noxious fume capabilities. It could have location sensors built into it. But basically the smart belt was worn by users down on that operations line. It could actually understand up to 27,000 payloads per belt to the cloud. Now, that sounds like a lot of work and payloads. What happens is it actually understands what's going on. So is the worker twisting correctly? How many times have they picked up certain boxes? Are they riding in forklifts? And is the forklift speeding or braking or other things from that standpoint? All of those different payloads are being built into a dashboard, which then can start to proactive capabilities with the employees. If the employee hasn't had a break in a couple hours, it can send out an alert to them and say, you might want to take a break. You've been going for 5 hours and you've lifted up 30 times or 40 times. And you might want to take a break and you might want to do some stretching to understand where that failure might be occurring. Human failure is a big issue. So what they've been able to do is the safety data is now brought to the customers 5 times faster, which has been able to reduce injuries of their employees by up to 30%. They've deployed this around the world as a service type of capability. So you can buy the smart belt, or you can use the smart belt on a daily type of a payment plan for going forward from those different users and different capabilities from there. They also have this for temperature reading and proximity sensors to understand when too many people are in a room, and other capabilities from there. So they're really an innovative company to help with that worker safety capability that we've talked about from earlier. Let's look at the next slide. Another example is Kony cranes, and many of you have these cranes in your environments. And what Kony is now available to do is not just manufacture and deploy these cranes, but also be able to do better maintenance plans with them. What they've been able to do is put IoT green grass onto these devices, which are incredibly large, capable and environments that you use on a day in and day out basis. But what they're able to do is understand how these cranes are being used in real time. They're able to build production maintenance plans. They're able to do predictive maintenance in case a crane might be failing, to understand when a failure might be occurring. Single point of failure many times on a crane is that hoist. And if they're able to understand how many times it was brought up and down, be able to do that predictive maintenance plan, and not just look at maintenance schedule capabilities, be able to look and understand the right maintenance plan to be able to understand that capability. This was difficult in the past because these were remote locations, but now what we're able to do is get that right data sets back to understand where those abnormalities are, those defects, those issues in the data that we're seeing, spikes or drops of what's going from that standpoint, and be able to bring that also with the local environment. So is it temperature? Is it vibration? Is it humidity in the room, which actually can affect how those cranes are working? So now what they're able to do is not just offer that as a service, so now they're doing maintenance as a service, but in the future, looking at even crane as a service, selling you lift. How many times are you going to pick up how many tons of equipment to be able to move that as you start to go forward and change that relationship with you, their customer, to be able to get better insights across that deployment path that you've been using for a long time. If we go to the last slide, you'll see that AWS has really built a lot of new capabilities for the industrial marketplace. One, by using a lot of the experience of AWS and Amazon, being able to deploy what we do in our fulfillment centers and give you that better insight of your operations about what's going on. Looking at the large deployments that we have from a hybrid capability, both on-premise and off-premise, both on connectivity and off connectivity, that if a network does fail, if you're no longer connected to the cloud for X amount of hours, your operations still have to work. So looking at edge solutions, looking at full capability to be able to do not just step change improvements, but leaping forward, having that new improvement, no longer just 1 or 2%, but as you saw with those numbers of things like OE improvements of 5 and 10, 15 and 20% type of capability, gives you better operational efficiency, better quality, and better agility to be able to react to the market in as close to real time as possible to stay ahead of deviation and curves that are happening out there. With that, I actually am 4 minutes early, and I'd love to open up to any questions.
Hey, Doug, I think we're going to move on. I think we're running a little bit tight here on time, given some other things. So I do want to thank you very much for your presentation there. That was great. Again, these sessions will be recorded and available for folks on demand if they want to go back and review any of these. And Doug and the other presenters' contact info is available if people want to forward direct questions there as well, or you can go through your account teams as well. So Doug, thanks very much for your participation and presentation there.
Thank you, everybody. Have a great rest of the week.